What's going on, everybody, and welcome to the second in our series of projects designed to give you a set of tools that will allow you to do your own statistical analyses in a way that not only allows you to get through this class and do the analyses that are necessary to demonstrate mastery in getting through this class, but also in perpetuity, to be able to do your own statistical analyses on your own, using your own set of tools here. It allows you to be a leader in your school and in your community as far as statistical analysis is concerned here. So you've been in statistics long enough to get a good solid introduction into what it is that we do as statisticians. You've probably noticed that there are two different aspects to what we do, and you saw this with the beanbag experiment where we had beads inside of a bag. There were really two different kinds of things we were doing. We were using statistics to describe the sample that you had pulled out of that bag, and the other was an inferential side in which you were trying to figure out what was in the bag based upon your analysis of what you had in your hand. Descriptive versus inferential. And so the set of projects that we're going to be doing here really reflects that distinction here. This first project is going to be one in which you get some skill in being able to do some descriptive statistics. We'll be doing some probabilistic things with some later projects, and then when we get to the last few projects that we have, those are going to be inferential in nature. So it follows that same dichotomy of descriptive versus inferential here. And so the one that we're working on right now is the one that's necessary to do in order to do all the other ones here. It's the descriptive part here. And so as I show you what the project entails here, by the way, this is project 2A here. There's really two parts to every one of the projects. One is the creation of the tool, and then the other one is the usage of that tool. So project 2A involves going through the steps that I lead you through here in this video, and so you'll be graded on how well you construct that tool based upon what you see there. Once you've done that, then you have to use that tool in order to do an analysis of a set of data, which you're going to pick out of a list. You'll be the only person in the class who is working on analyzing that particular data. But once you do that analysis, you'll hand that in, and that'll be counted as project 2B. So let's take a look here at project 2A here. We're going to be creating something that does descriptive stats here. So we'll need a clear worksheet title, clear directions on where to paste the data, and this sheet should output a 5-number summary of the data with the labels mean, mode, medians, sample variance, sample standard deviation, 15th and 18th percentiles of the data, and that's probably something that's a little bit that might not be familiar to you. We'll get into calculating those as time goes on here. But you probably are familiar with the next one, frequency table of a data, relative frequency table of the data. Actually, creating a bar chart out of the frequency table involves creating a histogram here. And there are other things here like a relative frequency polygon and a box plot of the data. There's also an ogive, which I'm adding to the list here. Should have mentioned that. So an ogive of the data there. So that's just a frequency polygon that involves the cumulative data rather than the individual frequencies. So that'll be pretty straightforward. You also have to have some degree of aesthetic prowess as you're putting this together here. You have to use a sensible use of 3 or more colors, a sensible use of 3 or more fonts or font styles, really making use of that stuff that you did with the creating that invoice, where you had to make use of colors and fonts to make that look really, really cool. So that's going to make it so that this tool is all the more friendly for you as you're using it in the class and beyond. You should know that as I'm doing this, I'll be testing your tool on a new set of data that it has never seen before, and it needs to calculate everything automatically and calculate it correctly in order to be counted as valid here. This is something that you should be able to paste some data in, that your teacher or somebody gives you, and at any given time, and it'll automatically calculate all these statistics for you and generate these really, really cool looking plots, and everybody's going to think that's kind of cool, and you'll be able to use that to immediately give some information about the data set here. It's a pretty powerful tool here. So what we're going to do is we're going to make use of a link that I created here to a spreadsheet that shows Fort Collins weather data for 2021. This is actual data that I got from weatherunderground.com. I think it's wonderground.com is the actual URL there, but that's what we want to do is just basically use a column of this data here. I think what I'll use is, what should I use? I think I'll use average temperature here. So I've got, it's important to understand what the data is and what it's not. Let me switch here to this. You obviously need to see this. So it's important to see what your data is and what is not here. Here's Fort Collins weather data 2021. It's got dates here, max temperature, min temperature for that day. This is January. So this whole row here is January 1st. This second row is January 2nd. It goes all the way down to the end of 2021. So I scroll back up here. This is max temperature, min temperature. If you average those two together, you get the average temperature for the day. Same thing for the dew point. The dew point is a measure of how much water there is evaporated into the air here. So it's how wet, quote unquote, how wet the air is. And so the higher this number is, then the greater amount of water vapor that's in the air here. So we also have relative humidity, which is another measure of the amount of water vapor that's in the air. We have maximum wind speeds, minimum wind speeds, average wind speeds, and barometric pressure here. That's in inches of mercury here. So max, min, and average. And then lastly over here we have any precipitation that we had for the day in inches of precipitation. So not a whole lot here, just 9/100ths of an inch, 1/100th of an inch, 3/100ths of an inch, 7/100ths of an inch. So didn't get a whole lot during this time. In fact, let me do this here. Find out how much rain we got the whole year here. Wow. When you select a set of cells here, then it calculates something in the bottom. Let me turn myself off so you can see here. Down here, you might be able to see that this says sum is equal to basically 1.53 inches. That's really just, wow, that's nothing. I hope that that's incorrect. Nevertheless, that's what this data describes. And so we can use this data as something that we can work with as we're building our tool here. So let's do this. Let's figure out first which data we're going to be working with, and let's work with average temperature degrees Fahrenheit. So I won't select the column title here, but I will select just all this data here going down. April, May, June, July, August, September, October, November, December. Okay, I'll stop there. And I'm just going to leave that selected for a moment here. And the way that we want to get this going is we're going to start up. We're going to go into our Google Sheets. And we're going to find that set of statistical tools that you created in Project 1, which contains your example invoice here. Okay, we're still going to use my statistical tools here. So I call this the name of the workbook here versus the name of the sheet. The name of the workbook here is my statistical tools. The name of the sheet here is example invoice, which is what you created beforehand. And if I click this plus sign, I can create another sheet. And this should be called descriptive stats. Okay, so you've got two different sheets here that you can toggle back and forth on. And they're all stuck inside the same workbook here. And by the way, what you're going to be submitting to me is exactly the same thing as before. You can click on this up here, and you'll just want to copy this link and paste this into the Dropbox that you use in order to submit this for Project 2A. All right, so let's come back here to this. We have all that data selected. And I'm going to go up to Edit and choose Copy. And what's a good place to paste your data when you're doing this sort of analysis? Well, I'm thinking that the leftmost column is probably an ideal location for us to do this. So I'm just going to click up here at A1, and then I'm going to go up to Edit and just choose Paste. Okay, and that's pasted all of those data there. It should be about 365 of them. Last year wasn't a leap year, so it should be 365. Okay, good. So let's scroll back up here. And then let's start creating some things here. There's a lot of stuff we're going to be calculating for this data. And let me piece together here for a second where I've got some stuff standing by for this. There we go. What I'd like you to do is to designate this in the future as the place where you will paste data. And so it's a good idea to highlight sections of your workbook, sections of your sheet rather, that are going to that people can paste data in the future. And then there are other cells that you don't want to mess with because they have machinery that's, you don't want to change that. But you do want to change stuff that's in this first column here, because this is where you paste your data. So I'm going to go up here and just choose a specific color that just indicates that this is stuff that you can change. All right, so just make that distinct here. And in fact, I'm going to put a label up here that says paste data. And let's see, how can I make a left arrow here? I think a less than sign and a dash, like this, in this column. Okay, so with that in mind, we shouldn't put anything else down here at all. So this should be all kept blank here. This column is just for storing the data. Okay, and let's put a title up here. Let's call this Descriptive Statistics. And let's see, I like to make my titles 18 bold in terms of fonts here. Okay, and so there's a few things we want to do. The first being that we want to do some initial analysis of the data here. And so I'm just going to give this a title, Data Analysis. And you know what, since that's a title, I'm going to make it bold with 14. I'll make that nice and big there. Okay, so that'll work. And I think I'm going to have a box here that shows count and mean. All right, and I'm going to right justify that. And I'll give it a bold face. I'll make it maybe a 12, something like that. And so in this box, I'm going to calculate in here and here what the count is of the data and what the average is of the data here. And so this is where we start to get into some of the functions that I introduced to you before. You saw a little bit of this last time, but not a whole lot here. This is kind of what we have here as far as functions are concerned. You might recognize sum of that was something that added up a set of cells here, and perhaps it's a good idea for us to review what this means here. A1 colon B3. What in the world does that mean? Well, for this, you'll notice here that the data, I just have an example portion taken from a sheet. You have column A, you have column B, you have rows 1, 2, and 3 here. And so A1 refers specifically to whatever is in this cell A1. And B3 refers to whatever is in this cell B3. And so when you have these two cells put together here, separated by a colon, that's describing a rectangle that starts in the upper left-hand corner with A1 and ends in the lower right-hand corner with B3. It's a way in which we can select an entire rectangle of data cells here that we want to input into a function. So all of these get input into this function, and this would return the sum of all these numbers here. I'm not sure what that would be. 5, 6, 7, 8, 9, 10. Kind of looks like it would be 24 plus 45, I think is what it would be. So that's the value that would be returned there. And you can see that this range notation here is used in quite a few different functions, including the next two that we're going to be using here. Count just counts up the number of data values in here. If this cell were blank, and we did count for this region here, the answer would be 5, because only 5 of the 6 cells actually have data. And average, as you might guess, this finds the average of all the numbers in these cells here as well. So that actually helps us out for doing what we need to do here. We're wanting to make it so that we are calculating first the count of the data and the mean of the data. And so over here, we're going to insert a function that allows for us to do just that. We're going to be inserting something here that allows for us to give a count of the data that's in here. So equals, what was the name of the function again? It was count. And inside here, I'm going to put a range, the range of all of this data here. So I was starting up in the upper left-hand corner and going all the way down here like this. And you can see it sort of built that range delineation form here. So A1 colon A365, that defines that rectangle that we just selected here. So I could hit the rightmost parentheses, and notice I get an answer here, 365. Now, that formula here works, but it's not the best formula for us to use, because what if the next set of data that you insert in here has more than 365 values to it? What if it has 500? What if it has 1,000? With the formula as it is now, it's only going to pick up the first 365 of those values, because we've told it to only search in the first 365 rows. What we need is to be able to change this formula here. I just double-clicked on it to pull up the formula. And we need to change it so that it's looking throughout the entire column here. And the way that we show that is to simply say A colon A. It's the way we indicate all of column A. And let's see if we can get the same answer here. But this would ensure that we'll get the right answer regardless of what our data is as we paste it in. We can do the same thing here with mean. The operative function here is average, and again the range is going to be A colon A, and it looks like the average temperature in Fort Collins, Colorado is about 51 degrees Fahrenheit, probably very similar to Greeley. Okay, so this is the first set of analyses that we've been able to do here. And in fact, I kind of want to select this whole thing here, and I think I'm going to want to put a boundary around this, a nice little border. I'm going to select the big border here, and I'm just going to put a border on the outer portion of this just to outline that. All right, so we're actually going to create another set of analyses here, and I call this the 5-number summary. Okay, and just like before, I want this to be 12, bold, and right justified, just like that. And let's see, let's skip down just a little bit here, and there are 5 elements in the 5-number summary. As you might guess, there's 5 numbers in the 5-number summary. Those numbers are the minimum value of the data, the smallest value, the quartile, the first quartile, the median, the third quartile, and the maximum. So in other words, what's the smallest value of the data? What's the largest value of the data? What's the data value that half the data are larger than and half the data are smaller than? So if we could divide the data into 2 equal halves, what would be the data value that's in the middle? And then Q1 and Q3 are the medians of the upper half and the medians of the bottom half. So in other words, a quarter of the data is below the first quartile. A quarter of the data is between the first quartile and the median. A quarter of the data is between the median and the third quartile. And you guessed it, a quarter of the data is between the third quartile and the maximum. So these 4 boundaries here, 5 boundaries here, effectively divide the data into 4 equal parts. Okay, so it allows for us to get a bird's eye view of what the data looks like here. So we have some functions for calculating some of these things. Let me pull these things up. We have this function here that calculates the minimum. We have this value that calculates the maximum, and we have this one that calculates the median. So min, max, median. Let's just go with those three for the moment here. So for minimum, min, and what's our range? A colon A, right parentheses, we hit enter. And let's do the same thing here for the maximum on bottom here. So max A colon A, 83.5. So 83.5 degrees as the average temperature. So the highest plus the lowest divided by 2, right in the middle there. That was our hottest day. Our coldest day was a little just under 6 below, just above 6 below, I should say. The median, that's a different command here. That's median, and it's the same data range delineation there. All right, so 50.3. So half the days last year we had average temperatures in Fort Collins that were above 50.3, and half the days were below 50.3. Okay, so that gets us at least these three here for calculating the 5-number summary. So let's go back here to our set of functions and let's see what else we can find here. What we're going to be using is something called percentile. All right, and you might have heard percentiles before if you've ever taken some kind of a standardized test of some sort. Sometimes they report back your score as a percentile, indicating how well you did in comparison to all other students here. So, for example, if you had a score in the 95th percentile, that means that your score was better than 95% of all students who took the test. So if you had an 85 on it, that meant that your score was better than 85% of all of the people who took the test here. So if you want to figure out, for example, what data value would be the 25th percentile here, we would put in 0.25 into this. We'd describe it as a decimal instead of a percent. And so this would give us the value that 25% of the data is below and 75% of it is above. Okay, so that's the function here. We put in the range and we put in the actual percentile value that we're going to be using here. So let's do that for this one here for quarter one. Here's our function, percentile, and our range again is going to be A colon A, and this is quartile 1, so we want to use the 25th percentile. It's 0.25, and that should give us that value there, 35.8 degrees. Now, how would the second one be different? Percentile again, same range, but what's the percentile now? Is it 25%? No, it's 75%. It's on the other side. And that gives us our quartile 3 there. That's our 5-number summary. So it describes the data set really in terms of 5 numbers very, very nicely, showing you the outer boundaries, showing you the middle, and showing you the quartile delineations there as well. I think I'm going to circumscribe this in a similar box, just like before. Make sure the border style is what I want. Yeah, so it'll look like that. Very good. Okay, and there's one other set of statistics that I want to do here. I'm just going to call these other statistics, just to be creative. Other statistics. Okay, so once again, I'm going to give it the same values that I did previous titles here. I think that's too big. Yeah, it's just 12, not 14. Okay, so bold, 12, right justified. Okay, and here's some of the other things that I want to calculate for this set of data. The mode, which is the most popular data value, by the way. What's the one that most commonly shows up on that list of data values there? Variance and standard deviation. usually I like to just abbreviate it with that, STD-DEV. The interquartile range, that's easy to calculate. And then lastly, the 15th percentile and the 85th percentile. This gives us another feel for what the outer reaches of the data look like. Okay, so for this, and I'm actually going to encircle this in another box as well. All right, so what are the commands that we use in order to make these things? Well, you probably already know what to do here for the percentile. Again, that's going to be the command percentile. It's going to be the same column of data, AA, and for the 15th percentile, we're putting that in as a decimal, 0.15. Okay, so nice and easy. Notice that's below the first quartile, that's the 25th percentile, so the 15th percentile would be a little lower than that. That makes sense. And then the 85th percentile, same idea here, percentile, A:A, and then 0.85, and that should be, that should be bigger than quartile 3, and it is, but it shouldn't be bigger than the maximum. It should be in between those. Very, very nice. Okay, love it. Let's see what the other commands are here. Let me pull these up once again. Mode. Well, that's nice and easy. Variance is var_a, and standard deviation is STD-EVA. Okay, nice and easy. So mode is just mode. Okay, nice and easy. Okay, so the most common data value was 74.8 for average temperature for the day. Variance, that's VARA, again, of the same data range. A:A. Okay, very, very nice. Standard deviation, STDEVA, and that's A:A. Okay, and so these two things give you an idea of just how spread out the data is. In other words, just how much the data flies out from the mean. Is it close by the mean? Does it hang around the mean very, very closely? So all of the numbers are very, very near 51, 52, 53, 50, 49, 48, or do they spread out quite a bit into negative numbers and really, really big numbers? So this gives you a rough idea of the spread of the data, as does the 5-number summary, by the way. Lastly, the interquartile range, you find that that's quite easy. All that is it's quartile 3 minus quartile 1. It's the difference between these two quartiles. These two quartiles between which half the data exist. Right? This is the middle half of the data, is in between 68.8 and 35.8, somewhere in there. Okay, so it'd be good to know how far apart those things are. All right, well, to do that, we type an equal sign, and we're going to type in, well, we're just going to click here on the cell for quartile 3, and then hit the minus for subtraction, and then this cell here for quartile 1. I'm going to hit enter, and the spread is 33 degrees between the first quartile and the third quartile. It's another measure of just what the spread of the data is there. All right, not bad. All right, now let's scroll to the right just a little bit here, using my arrow keys that are right behind me here. These arrow keys here. Okay, and I'm going to create another box of information here. This is frequency table parameters. The frequency table, as you might recall, requires that we know what the minimum and maximum values are, because we're setting up the table. It also requires that we know how many classes we want to create, and from that it calculates what the class width should be, and then it generates the table based upon that. So we're actually going to have it automatically generate the table here, not only for this set of data, but for any set of data. So we're going to teach it how to do that. Watch closely here. Let me first of all make this a title. I don't need to right justify it this time. I'll left justify it, but I'll make this bold just like before, and I believe that's 12. Yeah, so bold and 12. Okay, and you might not understand why we're doing this yet, but I'm going to type the word override, question mark, here, and next to it I'm going to write minimum in table. And I'm going to click up here. You can see how I can change the widths of these columns here. I'm going to make it so that it scrolls past that a little bit, so that the S in parameters and table doesn't edge beyond that. Okay, and I'm going to do the same thing down here, right where Q3 is. I'm going to say override, question mark, and I'll say maximum in table. Okay, and I'm going to make these the same color that I made this color here for the data here. By the way, you know, these colors don't have to be exactly the same that I'm doing here. I mean, I'm just kind of showing you something that definitely works here, but feel free to experiment a little bit with these things. As long as it retains its functionality, all is good. Okay, I'm going to color that cell blue. I'm going to do the same thing down here just below the other word, override. Okay, and so these two green squares should be the right, just to the right of the words minimum and the words maximum. What this does is I want you to be able to override what the minimum of the data is, so to sort of set what you want the minimum to be and to set what you want the maximum to be here. So that'll make it so that you can plot things a little bit more effectively. And then lastly, right in here, we're going to if you're overriding what you want the minimum to be, in other words, if you want this minimum to be in your frequency table to not be 5.7, but perhaps minus 10, might be a good way to do it. This basically checks this cell here basically just checks to see if this is empty. And if it's empty, it says take the value from here. If it's not empty, take the value from here. Okay, and so how do we do that? Well, we make use of an if statement, and that's this one down here. There are three parts to an if statement. All right, so the three parts are if, and here's some kind of conditional statement here. It either evaluates as being true or false. A2 is equal to 7, so A2 is equal to 7. In this case, it would be true, wouldn't it? A2 is equal to 7, and so what it does from there is it says if this is true, then go with this. If it's false, go with the one after it. Okay, so this allows us to evaluate a conditional statement here, see if it's yes or no, true or false. If it's true, go with what's here. If it's false, go with what's here. So that's the if statement. And so the idea here is this value here. We want to update this based upon this override. So if this value in this cell here, so I'm going to click on that cell, and we want to know if it's empty. All right, so how do you ask if something's empty? Well, the way that you do it is you just say equals and then quotation mark, quotation mark. Nothing in between the quotation marks. So equals quotation mark is if that cell is empty, and what are we supposed to do if it's empty? Well, we go with this value, don't we? The 5.7. So I'm going to hit the comma. Oops. Hit the comma. Value if true, we go with this, comma, and then what's left is value if false, and that's whatever's in here. So I just clicked in there. Then hit the right parentheses, and there's the value. Notice, in this case, it took the override at -10. If I were to click here and hit the delete key, now it's back to 5.7. Okay, so we're going to do something similar here with the maximum. We're going to use a similar if-then statement here. Equals if this value equals nothing, So this green rectangle here, this green cell is equal to nothing. If it's equal to nothing, what do? We go with this value. If it's not equal to nothing, we go with what's in that cell. Okay, it's asking for an autofill here. No, I don't want to do that. So reject suggestion. Okay, so you can see here it's ignoring whatever's in this cell here because there's nothing to look at. But if I change that to 79, there it is. I've changed it. I'm going to hit delete there so it goes back to listening to this. So I now are able to define the minimum and the maximum of my frequency table here. Now, there's one other thing that I want for people to be able to determine for themselves, and that's, of course, the number of classes. Okay, so there's that. You know what? I think I might want to scroll down and put that here. Number of classes. And I will make this cell green because this is a cell, again, just like this one and everything in this column here, this is a cell that people can mess with. All right, and they can put their own values in and play with it. Okay, and so for now I'm going to say 5 for the number of classes. And I want it to be able to calculate the class width based upon that information here. So class width, and it should be able to calculate that. And so how did we do this before? Well, we had to find the difference between the maximum and the minimum, and then divide that by the number of classes, and then round up to the next value. Okay, so let's do that one thing at a time here. So let's see, this is equals, and for order of operations to be right, I have to put that subtraction in parentheses here. So this will be parentheses. Let me just make those parentheses here first. And then let me move my cursor here to the middle of them. This is going to be this minus this. Okay, so we found the difference here in the maximum and the minimum here, haven't we? Okay, we'll divide that by the number of classes here. Okay, and you get this number here. No, I don't want to overfill. No, no, no. And I get 17.84. What was the thing that we had to do? Oh, yes, we had to round that up. But how do you tell the computer to round up? The answer is that you use a function called ceiling, actually, C-E-I-L-I-N-G, and then you have to enclose all of this in another layer of parentheses, this whole thing here. So ceiling for everything here. So in other words, you're going to take that number and you're going to hit the ceiling of the next whole number above it. There it is. That's our class width. Okay, and if I were to change the number of classes here, it automatically updates what that is. All right, very, very nice. And I think what we'll do is we'll make it so the maximum number of classes that somebody can choose is 20. We don't really want to get much higher than that. But yeah, if we go up to 15, we can make that class width nice and small. Okay, let me make it at 5. All right, so let's do this. Let's enclose this again in another box, just like before. Okay, very, very nice. Look at this. We've already got data analysis. We've pasted our data in there, and we've got 4 different sections of data analytics already put out here to describe this data. And again, if I were to change something in this or paste an entirely different column of data into this, everything would update automatically. Okay, so let's do this. This is the place where we're going to create our frequency table right here. And it's going to have a lot of different columns in it. And this is, so I'm just going to go ahead and set up what those columns are going to look like here. And so just follow me as I do this, and then it'll become more understandable as time goes on here. So I'm going to have you put the hashtag symbol here in the first one, £, and I'm going to have you hit tab for the next one over here. Type in class limits, and then skip a column over, and then type class limits again. Okay, and make sure you spell things correctly, Dr. Withrow. Okay, very good. So £, class limits, blank, class limits. Let's do class boundaries. Okay, and let's have a blank column right after that. And in our next column over, that'll be midpoint. And then frequency. And then relative frequency. And I usually just abbreviate it that way. And then let's do cumulative frequency, and I usually abbreviate it that way. And then cumulative relative frequency, abbreviated that way. And then, believe it or not, we're going to repeat these things again here. Not all of them, but some of them. So we're going to first do class limits, midpoint, frequency, relative frequency, cumulative frequency, and cumulative relative frequency. All right, so that was a mouthful here. So let's just review what these should be here. They are the £, class limits, blank, class limits, class boundaries, blank, midpoint, frequency, relative frequency, cumulative relative frequency, class limits, midpoint, frequency, relative frequency, cumulative frequency, and cumulative relative frequency. Okay, so very, very good. So this is the largest table we're going to be creating here, by the way, and you'll get an idea of just how big it's going to be here by what we put below this £sign here. Let's do numbers going from 1 to 20, 2, 3, 4, and I'm going to fill this down here all the way down. I thought it would be 17, 18, 19, 20. Okay, so I can zoom out here a little bit. Okay, so we're getting a bird's eye view here on what this table is going to look like. So first I'm going to, I think what I'll do is I will make it so that there's a box around all the titles here. And by the way, I'll make all those bold. And I'll put a large box around all of them. And then, let's see here. I'm going to put a box around this. Okay. And here's what I'm going to do here with class limits. The difference between the class limits here and the class limits here is that this will show all of the class limits in one. In other words, this will show, 5 to 10, 15 to 20. This will show the class limits showing the lower limit here and the upper level and the upper limit just in separate columns here. And so that'll be necessary for calculations. So let me do this here. Let's see, that's as far down as this goes. So I'm just making another rectangle here to create another box. And I'm going to do the same thing here, but just I don't want to make them into two separate columns. I want to box them as one entire whole here. And in fact, let's do this here. You see where it says class limits? I'm going to select both of these cells up here so that both of them are selected. And then I'm going to go up to Format, and I'm going to say Merge Cells. I'm just going to say Merge All. Okay, that doesn't look like anything changed there, but this is now one cell. So that, for example, if I now choose to center this, it is centered across a single cell now. So even though there are two columns beneath it, this one is just a single cell up here. With that in mind here, let's actually center all of this stuff as well. Okay, that looks nice. Let's make them all bold-faced too. Okay, let's actually center these as well. That'll look nice here. And let's do the same thing here for class boundaries. Let's select these two columns here and merge those as well, so that now that's appropriately centered above these two columns here, isn't it? So there we go there. And let's just do the same kind of thing here with midpoint and frequency and relative frequency, cumulative frequency, cumulative relative frequency, and class limits, midpoint. And you're probably again wondering why these things repeat, and you'll find out soon. Frequency, relative frequency, cumulative frequency, and cumulative relative frequency. Okay. All right, very nice. Alrighty, so let's think to ourselves how we're going to create, first of all, these class limits like this. Let's go to the left here and think about how did we create this lower class limit here? How did we do that? Well, we got it from none other than the minimum that we are choosing from our data here, or by overriding it with something else here. So this lower class limit here is going to be whatever this number is here that we're choosing for our minimum in the table. Okay, so this here is this. And so there we are. No, I don't want to overfill. Autofill there, I mean. Okay, so we've got our first class limit put in here. And how did we calculate these things again here? Well, we just calculated them all the way down by taking each one and taking by causing that to be equal to, actually let me zoom in here so you can all see this. So each one, this first one here started off as being equal to this cell. And then this one is going to be equal to this cell plus whatever that class width is, isn't it? Okay. And here's something special I want you to do here. Now that you've chosen this cell for class width, you can see that the cell here for me is E19. It might be something slightly different for you. If you've placed your tables slightly differently, that's okay. But in front of the letter and the number, E and 19, I want you to put $ signs just in front of it. You'll see why in a moment. Okay, and then hit enter, and you'll notice that it took this and added the class width to get the next one. All right. I want to be able to fill this down here very quickly here, but you can see my formula here. When I fill this down, then this next one down is going to take a look at at its environment relatively in the same way that the previous one did. So this won't be looking for I4. It's going to be looking for the one. This cell here is the one that's directly above this one here, and so this one's going to think of it the same way. I have to go to the one that's directly above where that is for me. So as I fill this down, you'll see this formula now is slightly different. It's not I4, it's I5. So it's understanding that relative to the location of this cell, I should again choose the one that's immediately above it. It's filling it down that way. So it's changing the cells in their formula. We don't want it to change with regards to this class width. We want it to always be looking in the same location for the class width here. So that's what these $ signs are doing. It allows us to fill these things down here. So I can actually fill this down all the way down here to 20. And in fact, let's fill it even farther, just one below that. How did we find this value up here? Well, it was this value minus 1, was it not? All right, so this value minus 1 is how we found what was up here. And so let's do that. That's equal to this minus 1. There it is. And this is equal to this one minus 1. All right, I should be able to just fill that down here all the way down to the bottom. Okay, as you can see here, it messed up some of my formatting of this, so let me just select this section again here and then recreate this here. By the way, it needs this in order to have this thing to have something to look at for creating its final value here. If you want to hide this, you could make it so that its font is in white. So it's written in white, can't see it. Okay, so that comes from choosing the font color here as being white. Okay. So this lists out the class limits numerically into two separate columns here. I want to also be able to describe the class limits as put together with a dash in between them, something that you'd have for a label or something. And so the way that I want to do that is to zoom in here. I'm going to click on this cell. I'm going to hit equals because it's a formula. And I'm going to say I want it to look like this. And then I'm going to add this to a set of text. And so I'm going to use the @ sign for this. That's Shift 7. And then I'm going to put a dash in between it. So I have a dash in quotes. Then another @ symbol. And what's left? Well, it's just this number here, isn't it? So in my case, it's I4 at quotes dash at J4. And look at what it creates here. All right, very, very nice. And I can also fill this down so that it'll do the same for all the others here. And of course, that's going to mess up my... oh, no, it didn't do too bad. Probably want to center that very nicely. And maybe I want to put a space in between those two things here. So let me change the formula here. So there will be a space on either side of that dash. See, like that? And I think if I do that, see, that looks a little nicer, doesn't it? So with a space on either side of that dash, I'm going to fill that down again until I reach the bottom. See, that looks good. Okay, let me zoom out just a little bit here. And now I can redraw my outer rectangle there, so that's nice and neat. And then let's also make sure these are centered. See, isn't that nice? Those are all my labels here. Now, you've probably noticed that some of these are ridiculous. These are we're not going to use all of these class limits here. There was no temperature in 4 columns of 353 degrees. At least I hope there wasn't. So the point is that we're going to fill everything in these first few columns with all the possible information, and then to the right here, we're only going to show the row. We're going to use the same information, but only for the rows that are appropriate for our usage. Okay, how did we calculate our class boundaries? Well, it was just really each one of these class limits adding or subtracting a half. In the case of the lower class limit, we just subtracted a half from it. So let me do that. That's equal to that minus 0.5. Okay. And then this one up here, that is equal to this plus 0.5. Okay, so I've got these two formulas right here, and I could select both of them and then fill them down here. Okay, very nice. So those are appropriate class boundaries. I'm going to create my rectangle again, and I'll center them. There we go. How did we find the midpoint? Well, we found the midpoint either by taking averages of the class limits or by taking averages of the class boundaries. You can do either one. Either way, it's adding them up and then dividing by 2. So make sure that when you're adding them up, order of operations, you got to stick the addition in parentheses before dividing by 2. So this is going to be equals parentheses this plus this, right parentheses divided by 2. You didn't think you're going to be using algebra here in statistics. Interesting. Well, there it is. There's our first midpoint here, and you can see it's right in between these two class limits, right in between these two class boundaries. Very, very good. So let's fill that formula down and make them all centered. And let's recreate our rectangle. Very nice. Frequency. Okay, so this one involves a new formula here, and in particular, it's a variant on the same count formula that we used beforehand. Remember that count formula that we used for figuring out the number of data cells that we had. This was count the number of data cells there. So in this case, we have to count the number of data cells, values of data in that column that meet a certain criteria. Okay, so for this frequency, it's everything in between this and this, isn't it? All right, so between these two things, for this frequency, we've got to figure out how to do that. Well, that's another one of our formulas. Let me pull this up here. So here's the formula. There's a formula called count, which involves counting everything. There's a formula called count if, where you count everything based upon one criterion is singular, criterion, and then count ifs for counting up a series of data that meet 2 or more criteria. And in this case, we have to find data values that are bigger than something and less than something else. That's 2 criteria. We need count if s. So let me select all of this here and let me just paste this in here just as a template. So it's going to be count if s. Let me first of all make the range correct, like that. Let me zoom in a bit more here. Yeah, it's not going to give a correct value now, but let me zoom in a bit more here, like this. Okay, and I want to put in the same data range here. Okay, and you can see that I've already got it set up here to be greater than or equal to something and less than. I shouldn't have that as an equal. That should be less than. So greater than or equal to this, and then less than equal to something. Well, I'm going to look here at the class boundaries for what I'm figuring out here. So let's do this for greater than or equal to, then the @ symbol again, and then this data value. So greater than or equal to that, and then this will be less than @ symbol, that data value. Let's see what we get here. 4 values. All right, so there were 4 days that had a average temperature in between those two extremes. Okay, so and we can most definitely fill this down. Ooh, something's wrong. Oh, no, it's right. That's right. And in fact, if I add up all these numbers here, you can see in the lower right, let me turn me off. In the lower right, it's adding up all these numbers here, and as expected, it's 365. So the the frequency table is accounting for everything. It's counting everything once. It appears to be functional. Okay. So very, very nice. And for count data, I kind of like to make it right justified here, but let me make the box correct again. Very, very nice. How did we calculate relative frequencies? As I recall, we took all of these numbers, each one of these numbers, and divided them by the same number. It's the count of all the data, which we have stored over here. Okay, and I wanted to always be looking at this location for the count of the data, but I wanted to do that I want each one of these numbers to be divided by it to get our relative frequency here. So in each case, our formula is going to be equals this divided by, where is it? It's that. Okay, so it's just the division of those two things there. Let me hit enter so that that's there. And let me double click on this formula here again. I want to make sure that we're always looking at C6 for that denominator there. So I'm going to make it so that we have dollar signs on both in front of both the C and in front of the 6 there. So we've got that. Now I'm ready to fill this down once again. We should see a bunch of zeros here at the bottom. Yep, and all of these numbers should add up to 1, which they do. Okay, recreate my rectangle. And then, let's see, how do I do cumulative frequency? Well, what's the first value here for the cumulative frequency? Well, that should just be this, shouldn't it? Nice and easy. The one below it should be the cumulative frequency from before plus the current data value, the current frequency. So it's this above plus this to its left. So now that should be 46. And this is the formula now that I should be able to fill down all the way to the bottom here. Okay, and it should end with 365. That makes sense. Let me select my full rectangle here and repair that. Okay. Now we're going to do the same thing but with the relative frequencies here. So this will be equals this, the relative frequency, and then below it, it's going to be the previous cumulative plus the current relative frequency. So the one above it plus the one to its left. All right, and that's the number I can fill down. And this we should see a bunch of ones here at the bottom. Good, good. Okay, I can recreate that rectangle again. And that's all set. Okay. One last thing here. Let's make it so that it responds to the number of classes that we've decided for it to have. Let me zoom out here for a little bit. And you can notice here that we've created a frequency table here. The only thing that's wrong with it is that we asked to see 5 classes, and so only the top 5 here are really of any value. Okay, everything else is just, chaff that should be removed. So this is sort of like scratch paper, and the final version of our frequency table is found in these 6 columns here. So this is actually the sort of ready for prime time version of our frequency table. And it just involves doing a simple check on some things that allows for us to make sure that everything is okay here. And it's going to involve, in each case, an if statement. Let me zoom in once again. Okay. And in each case, what we're comparing is the lower class boundary with the, I think it's the maximum value here. Yes, it's the maximum value. That's right. So in each case, we're going to be doing an if statement. And the question that we're asking is whether or not this is uh, this is one of the 5 we should be including, or if it's not one of the 5 that we should be including here. So the way that we check that is to ask, is this lower class boundary less than or equal to the maximum value here? Okay, and I always want it to be looking, this one's a little bit harder to control. I always want it to be looking at the minimum in a specific cell there, so F and 15 are going to have dollar signs in front of both things. This one right in here, I want it to be able to move down and up, but not to the left or right. Okay, so that means I want to have a dollar sign in front of the L, so don't move the column, but you don't have a dollar sign in front of the 4 here, so that it can move up and down the column. Okay, hard part's over. That's the hard part right there. In fact, that's the hardest part of the whole thing. So if that's true, then I just need to go and pick up the class limits value here to the left. And if it's not true, then I just want to leave it blank. Okay, so all that this did was it picked up what was over here and advanced it to the final draft by noticing that this class boundary down here of negative 6.2 is smaller than the maximum that we want to have in the table. Okay. And in fact, we can fill that down, and we should see something rather peculiar. Notice all we see are the class limits of the first 5 classes. So all these extra ones where the temperature is getting up to 350 degrees, not part of the final frequency table here. We just have these right in here, and let me center these since it's a label. And let's recreate that rectangle, and let me just review what that formula looks like here. So it's all about if this lower class boundary here is less than or equal to this maximum in the table. Okay, and you want dollar signs in front of everything except the in this case the 4, the number showing the row that the class boundary should be in. So we want to be able to go down all the rows here, so I don't want to hold that in place. Okay, midpoint's going to be pretty much the same idea here. We have the same test as before. So let me actually just, whoops, just take this and just copy it over like that. I didn't mean to copy it over 2 spaces here, but that'll still work. Notice when I copy it over, it's still looking at L4 and F15. So that's good. Still looking at the lower class boundary. And L15, F15 rather, I should say. Okay. But now let's see if I've got this right here. This is the midpoint, and the midpoint is located in column N, not column L. So this should not be L4, it should be N4. So we have the frequency there. So let me, I'm sorry, the midpoint there. So let me, okay. I've got all my midpoints here. Let me clean this up a little bit by first clearing all the borders, and then putting my single border around there. Okay, that looks better. Frequency. All right, the conditional at the beginning looks correct here, but let's see, where do I find frequencies? Frequencies are in column O, so this should not be M4, this should be O4. If I hit enter there, that's that. And I can fill that down as well. All right, relative frequency. Again, let me just copy paste over here. Okay, my conditional is correct, but relative frequency is stored in column P, and oh, so that's right. For that matter, no, let's just keep going it this way. Okay, so let me fill that down. Okay, that looks good. Clear all the borders, make a border around it, and we're good. There's our relative frequency. Cumulative frequency, let me click and drag this over here to copy that formula. The conditional is correct. Cumulative frequency is in column Q, so that's nice and easy. Let me fill this down. Clear out all of the boundaries and make one around the rectangle. And then lastly, cumulative relative frequency. And again, the conditional is right, and cumulative relative frequency is in column R. So I can just fill this down. And let's clear the boundaries and put a nice rectangle around it. Okay, so very good, sir. So notice we've got a lot of blank space in the lower portion of this, as it should be, as we want. So let me zoom out here a little bit. In fact, let me zoom out a lot. And as you can see, if I try to change the number of classes here to 10, now more of those rows are going to light up. Now keep in mind, we're creating a frequency table of the same data. So this is another frequency table here. It just has a class width of 9 instead of what we had before here. I can change this again to, let's say, 15. So now we have even more of these. All right, see, so that's how that's working out here. Class limits look nice. Let me do an override here as far as what the minimum is. Let me make the minimum -10, and it changes them accordingly here. That actually kind of makes the class limits a lot nicer. And for the maximum, let's do 85. Okay, that didn't really change things very much. The maximum doesn't, really play a whole lot of a role in the creation of the frequency table here. But as you can see here, it looks kind of nice. Class limits look good. Midpoints are calculated correctly. Class limits look good. Midpoints, yeah, that's right. That's right. Frequencies, relative frequencies, cumulatives, and cumulative relatives. Very, very nice. That looks great. So we've got the computational part of this done. All we have to do now is to create some plots. And we have 4 plots that we want to create. The first one is a histogram. And so we're going to be doing insert chart quite a few times here. Let me zoom out again. Okay, and we're going to be focusing specifically on this section over here of the data, the prime time section of this data here. Now, in order for us to do a histogram, we want to make use of class limits and frequency. Class limits and frequency. So midpoints in between, it's just going to be an annoyance. That's okay. We'll just select these 3 columns here. Then I'm going to go up to Insert and say Chart. Okay, and it's creating a bar chart here. That's the default. And a histogram is in fact a bar chart here. Let me first of all mess with the data here that we're looking at. So the x-axis indeed should be looking at that class limits variable here. So we have these class limits listed at the bottom. And it looks like it's plotting 2 different series of data here. one being stuff in the midpoint column and the other being stuff in the frequency column here. We only want the stuff in the frequency column. So I'm going to hit the three buttons over here, and I'm going to say remove this series from the plot here. And this is our histogram here. That's how that looks here. And in fact, let me spread this out a little bit here so that those data values aren't scrunched up there so much. Okay, so let me mess with some titles across the top here as well as underneath and on the side. So I'm going to switch to Customize, and I'm going to say Chart and Axis Titles. The chart title here, we're going to say Data Histogram. Okay, I'll switch this to Horizontal Axis Title right here. Right now it's set to Class Limits. That works pretty well. Vertical Axis Title, let's say Frequency. Okay, and you can see those appear right there. I don't like how small that font is. Let's see if I can make it a little bigger here. That seems about right. 16, was this 16 as well? Oh, that was 18, so let me make this 18. Okay. So there's our histogram plot, very nicely. And notice 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It's only reading the 14 rows of data in here. It's ignoring the ones that are blank. So for example, if I change the number of classes to 6, it's going to update that histogram automatically. Isn't that cool? Don't we like that? Okay, so that's our histogram. Let's create a relative frequency polygon here. This is another way in which we tend to show this sort of stuff here. We're going to be making use of the midpoint and the relative frequency, those two columns of data here. We've got frequency in between them, so I'll select all three columns here. It's going to be a line graph here, so slightly different than what we had before. Insert chart, and again the default is that it creates a bar chart here, so let's change that to a line graph. And let's see, what are we looking at here? We want the x-axis here to be the midpoint, so I'm clicking here where it says add x-axis, and you can see midpoint is an option here. I'm going to choose midpoint. That means I don't need midpoint to define the y-axis here, so I'll remove that. And I don't want frequency either, I want relative frequency. Okay, very, very cool. Okay, so this is our line graph. Let me make this as big as the others. Let me first of all create a title for this here. Customize, chart and axis titles, chart title. This is going to be a relative frequency polygon. And let's see, on the vertical axis, we want to have, let's see, relative frequency. And since we're using the midpoint to plot each one of these data values here, I think on the bottom we'll just say class midpoint. And I think I'll make these fonts the same as before. So bold 18, bold 18. I think I made this bold 24. Yeah, looks pretty good. Okay, so we can already take a look at what we're seeing here. We can see that there were some instances in which Fort Collins went, below zero in its average temperature last year, and also below freezing here. But you can see that the majority of its time it was between 22 and 85 for its average temperature. And that's its average temperature for a day. That meant that it could get, that doesn't mean it could still get much hotter in the day than 85. And so you can see here that most of Fort Collins' weather is within that particular range here, with some occasional extremes in cold. Frequency polygons are sometimes used when we want to show a bunch of distributions all at the same time, and so we want to make it so we can just plot the lines together on the same scale. They're a little less intrusive than showing bars, and so this is another way of showing the same idea here. By the way, one of the things you're going to be doing is you're going to be comparing two sets of data here. And so if you're comparing two sets of data, you'll probably want to make it so that your histograms have the same minimum and the same maximum, that they're going from one thing to the other. So that'll make it so that as you're comparing one distribution to another, you're comparing apples to apples instead of apples to oranges. So if your histograms have the same, are defined in exactly the same way with these overrides, then you'll be able to do that. So hence the need for the overrides. So keep that in mind. Let's create a third one here. This is very, very much like our frequency polygon, except we're using the cumulative relative frequency instead of the relative frequency. So this is called the ogive. So we're using midpoint up here and the cumulative relative frequency. So I'll select those columns, select all those ones in between. We'll just have to say, no, we're not using those. No, we're not using those. Insert chart. Once again, it's a bar chart. Let's make it a line chart. Let's move it down. Let's make it the same size as the others. And let's see, what should we have on the x-axis? Oh yes, midpoint. And what we want to have on the y-axis is specifically this cumulative relative frequency down here. And we should get rid of everything else. So remove, 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 and remove. So there we are. This is an ogive. So it shows how, as we move in data values from left to right here, how closely we move from 0 to 100% of the data. Okay, so we can create our chart title here. This will be data ogive. And let's see here. Horizontal axis title, class midpoint. Oh, it's lit up for me there. Very nice. Okay, class midpoint. And then for vertical axis title, this should be cumulative relative frequency. Okay, there we are. Very nice. And then lastly, we want to create a box plot. Now the box plot is unusual in that it doesn't really look at a column of data, but it takes a look at the 5-number summary that we work with here. So the 5-number summary, as you recall, was among those first sets of data that you created in the beginning here. And it's actually just going to pull all of those 5 values in the creation of this box plot. So we have to kind of do something behind the scenes in order to make it so that it can see it. What we want to do is to just do this here. In this cell, over to the far left here, just type the word data. And then, as we're going from left to right, what I want you to do here is to Let me zoom in. What I want you to do is to make this equal to the minimum. And this is the data minimum, not the override minimum that you did here. This is the original data minimum right there. So we click there, and there it is. It should be just copied to what we see here. This here should be the first quartile. So that should be that value. This should be equal, should be equal to the third quartile. And lastly, this is going to be equal to the maximum. Just like that. So this is the version of the data that the box plot is going to call its information from here. So if I select this and I go up to Insert Chart, it's a special kind of chart we're creating here. You have to scroll down in order to find it. It's this one here. It's the candlestick chart. It is, let me show it again here. It's the candlestick chart. Right down here. Okay, so and I unchecked these two boxes here so that we could, so that since they really didn't apply, and as you can see, those four data values, they're D, E, F, and G, got copied into these places right in here. This is actually we're kind of jerry-rigging something here because these plots are actually used for tracking the stock market here. So they're called candlestick plots because of their shape. So they look kind of like box plots, but they're missing something. What they're missing is this line that goes through the center here that would indicate the median rather, but it's close enough. And so what I want to do is, let's see, I think the only thing that's left really, data is okay for down here, but let's say, probably we should change the title, but that's about it here. I'll make this value, and then I'll make this data box plot. So customize, chart and axis titles, chart title, data box plot, 24 bold, and this right in here. Vertical axis title, that's just going to be value. And we'll make that 18 and bold, and then on the bottom here we'll do the same thing with the horizontal title. That's going to be 18 and bold. All right, let me zoom out. Close this. We make this as big as it needs to be here. Okay, now let me really zoom out. So you can see here what you have at the end of this is you have a set of data that you've analyzed here by calculating the number of data points, the average, the 5-number summary, other statistics as well. You've created a frequency table here that responds to the number of columns that you want to use here, and you've got some tables, a frequency table and a set of graphs that update themselves accordingly as well. Notice that the box plot doesn't change here. That's because the box plot's not looking at any of these parameters for the frequency table here. The box plot's looking exclusively at this 5-number summary here, which is only looking at the data and nothing else. So you can probably select this right in here since this doesn't really help to see, and we can make this font white there so that it disappears from apparent view here. So this is what you needed to create here. This is, that's probably the most complex of all the sheets that you're going to have to create here. I'm taking a look at this. This was an hour and a half long. They won't be as long as this in the future here, but I think you'll find that this is a very, very useful tool here that you're going to be working with quite a bit and enjoying quite a bit. It's hopefully you're making it as user friendly as you possibly can here. Let's review what the what the objectives are of this. If I can pull this up here. Yes. So notice that this project here, descriptive stats, a clear worksheet title, we have that. Clear directions on where to paste the data. You recall we did that. The sheet should output a 5-number summary of the data with labels, mean, mode, sample variance, sample standard deviation, 15th and 18th percentiles, a frequency table of the data, relative frequency table, histogram, relative frequency polygon, and an ogive of the data, a box plot of the data. Sensible use of 3 or more colors and sensible use of 3 or more fonts. Might want to spend a little time on those to update those things. I don't think you need my help in order to finish those out here. But be aware, I'm going to test this with a new set of data to make sure that it functions properly. And you'll be submitting this with just by submitting the link to the Dropbox here. And so that concludes Project 2A. You'll then be using this particular tool that you just created in order to do the analysis necessary for Project 2B. All right, so hopefully that's helpful to all of you. I will see you in class.